We're moving into a block of lightning talks now. We are having more than planned due to a speaker that was not able to join us today. First up is Will Hargrove. Will.
Hi everyone, my name is Will Hargrave. I'm a technical director at LONAP, which is a mid-size internet exchange in London, UK. And what I'm going to talk about is a technique we've developed that reduces the impact of maintenance that an IXP operator does on the internet, basically. So, I'm going to start with simple stuff, which is kind of silly. I'm aiming a presentation at IXP operators and explaining what an IXP is, but stay with me on this. So what is an internet exchange? It's a switch fabric for interconnecting networks. BGP is the control plane, which is how the routers that are connected to it, they signal reachability to each other. So what actually happens to the production traffic on the internet exchange when the IXP operator does some maintenance? Here's a typical internet exchange. You've got two routers at the bottom there, which are the ISPs or other networks, and then we have a bunch of switches at the top, and we have a BGP session between them. All stuff, simple stuff. So I'm the IXP operator. I need to do a software upgrade on the box. So I do some stomp on that switch on the right-hand side. So what state are we in now? Well, the routers they're sitting there with their BGP hold timers running. They're still sending traffic, trying to send traffic over the internet exchange, and all the packets are leaking out onto the floor. This is all your users' data, and it's being dropped. And they're sitting there thinking, well, where's my peer? The timers are running. So then, 30 to 180 seconds later, the hold timer expires, the dead times expire, and they tear down the BGP sessions, and they move the traffic to a different route. That sucks, right? This is not a great way to run an internet. So how can we improve this experience? Well, I've already said it causes some black holing. So we're doing it actually the wrong way around. Let's think about an ideal way of doing this. At the start of the maintenance window, we tear down the control plane, we wait for the traffic to go away, and then we do the maintenance. Okay? So the problem is I don't have logins to all of my 140 plus member routers, and neither is that a good idea. But what we can do is we can put layer 4 ACLs on the exchange operator's edge ports, blocking the BGP at the start of the maintenance window. Here's a sample ACL. So I'm blocking, say, from source address of my IXP subnet, TCP 179, i.e. BGP. You need to block it in both directions, otherwise the sessions will reestablish in the other direction because BGP can work either way. You obviously need to do that for V6 as well. So we tested this during several on-net maintenances. INX have also started using this technique. Traffic typically goes away in a few minutes. And the advantage being that you remove the ACL when you're actually ready. So sometimes the upgrade screws up, like you forgot to change the boot variable and you rebooted the box and it came up with the same software. We've all done stuff like that. In this particular case, you can then restore the traffic when you're actually ready. And basically, I think this is a pretty simple technique. Everyone's I've spoken to has been pretty interested in it. Doesn't seem to have any bad effects. And makes a better internet. So we're thinking about maybe making a document of some sort about this to explain it. And that's it really from me. Any questions? Stunned silence.
Scott Lybrand, Limelight.
Oh, hi Scott.
I saw this presentation in Europe somewhere some months ago. Is anyone else doing it since then?
Yeah, INX have started doing it, and I thought while I was here at NANOG, I would maybe explain it to some internet exchanges in this room and see whether. Or I'm also interested in networks standing up and maybe shouting at me for layer violations or messing with their BGP or any of those kind of things. So, thanks.
So yeah, actually, I think this is really helpful because it has the ability to remove the control path before the data path goes away, which of course is critical to why it's able to help take traffic away from the exchanges more gracefully. This is actually something we've been doing for some time, even on our own routers, as a convenient way to terminate BGP sessions during maintenance periods too. Okay. So it's actually glad to see that this is getting a new application on the layer 2 side-ish.
So do you do that because it's just easier than altering the BGP config?
Yeah, we do it when we take entire nodes out of service because it's easier to just filter all of them,
Okay.
and it allows us to control like individual links without having to associate to the layer 3.
Yeah. I usually get comments like, well, why don't the members turn down their BGP sessions during the maintenance window? But I mean, we all know that no one actually ever bothers to read maintenance notifications, and they just like wait until they happen and phone up the NOC or something.
Anyway, thank you.
Thanks.
Will, I'll echo both you and Mike. I think this is a great idea, and I'll answer that, yeah, I think it is time to propose it as a BCOP.
You can do it in Equinix?
Actually, Eric Rosenberry from NWAX, I was going to make the exact same comment. We actually just on Friday finished our last migration from physically Oregon Health Science University's cabinets over to a new cabinet where we have our own space for the new legal entity, which we're talking about a little bit later. And we had to move 50 members, and it was a pain because, I mean, at first we gave everybody several windows like, hey, you know, call into bridge this time, shut your sessions down, check light levels, you know, we'll run ping tests and stuff before you bring them back up. And then the last window was like, hey, we're moving you whether or not you do coordination or not. And it was a royal pain in the butt. I love the solution, and thanks for presenting this. You should definitely write it up and get it on the internet.
Thanks very much.
Thanks, Will.
I'm going to run away now.
Yep, Mike.
Oh,
One more. Mike Hughes, Ethernet Consultancy. You mentioned about layer violations, and I know that I think Links had legal advice not to do layer violations. Is the idea saying basically doing the best practice, is that to deal with the specific issues there, such as not, basically you're only interfering with the signaling data and not the user data?
Yeah, I mean, it's an interesting point. I think some of that is, we don't want to admit that we can do filtering on an internet exchange, but I mean, everyone in this room knows we can. One interesting thing is that we're actually blocking traffic to and from our IP addresses, the internet exchange's IP addresses, right? It's kind of, that kind of means it's rather different to blocking arbitrary internet data.
Thanks, Will. I just thought it was worth pointing that out.
Yeah, great, thanks.
Thank you.
Thank you, Will. Next up, we have Lee Metcalf with CERT talking about DNS cache poisoning. Lee, welcome back to the stage.
So I don't just study routing, I also study DNS, and I'm glad to follow the guy from Farsight because this is their data. This is a big passive DNS source called the Security Internet Exchange that I studied, and I happened to run across this and thought, you know, it's really important. So here we have the lovely legalese. Everyone enjoy the legalese. The downside of legalese means that I can tell you if you ask me directly if you're affected by what I'm going to talk about, but I can't announce who's affected by it from the stage. So, this is weirdness I found in DNS. Because like with the routing study I did, I'm sitting on the outside looking in, I don't know what causes it. But I do know, what if the IP address you're sending email to as an MX server is not actually the IP address of the MX server you think you're sending it to? This isn't theory. This is actually occurring right now. What I see, I found in the Security Internet Exchange, I see the response IP that gives back the response to the query. Now, some of these are quite valid name servers. Some of these are guys just, oh, hi, I'm a name server today. And what they're responding back for, let's call it foobar.com, is it's applying a different IP address than it should. Well, yeah, that's a CDN. Duh. However, I filtered those out and it's still going. What's left is the bad stuff. And it's mostly out of shared hosting, so again, I don't know what's causing this. I don't know if these are name servers that have bad name server IP addresses that they're sending their queries to. I don't know if this is clients. One of the things about the Security Internet Exchange is it filters out personal identifying information. I don't know who's making these queries. I just know the response. I know that the TTLs seem to be exceedingly long, so when you think you're sending your email to foobar.com to its lovely MX server, and you've got the IP address, you've got it for a week. So what to do? DNSSEC, that's a lovely thing. Great thing. Standard user can't do a thing, really. I mean, I send email all the time. I don't pay attention to what IP address it's going to. I just kind of send it on. Enterprise, I can tell you exactly, if you subscribe to the Security Internet Exchange, how to find it. You're not going to find it within your network. You're not going to find it on your name servers. This is happening outside of your name servers. How has this gone unnoticed? You got to have the Security Internet Exchange and have the fun that I did. It's just not something you can find easy. You can only really notice it if you're looking for two different values. If you expect the one value back, get the one value back, you're happy. But if you get two values back, hey, something's wrong. But you really can't find it unless you're querying the right name servers. And yay, data sharing. Because of the Security Internet Exchange, that's how I found that, and that's big data sharing. Probable causes, we've kicked around any number of reasons to do this. The vulnerability team at CERT is kicking around any number of reasons to do this. I don't know what's causing it because, like I said, I'm from the outside looking in, and all I see is these IP addresses. And part of the reason it's so hard to find is some of these IP addresses actually give legitimate responses back, and they're only really targeting certain places to give the bad IP addresses back. But if it's you and you're an enterprise and you're looking directly and knowing what you're looking for through the SIE, you can find it. And do you have any questions? Like I said, if you want to know if you're a compromise and you come ask me directly, I can answer that question. I just can't talk in this big thing.
Quick side note, Alexander Lemon, Curator Labs. You should realize that latest countermeasures to DNS AMP, DNS rate limiting, also creates perfect opportunity for DNS poisoning because the window between responses is a good window to inject authority section. So take note. Thank you.
Thank you.
Great. Thank you very much, Lee.
Okay, I will be here till tomorrow if anyone wants to find me and ask me if they're compromised.
All right. Thank you very much, Lee. Coming up next, we have Lee Howard talking about an IPv6 transition date.
It'll surprise everybody that I'm back to talk about IPv6. There's this problem. The benefits of IPv6 are it's a network protocol, right? So there's a network effect problem that IPv6 isn't especially useful until more people are on IPv6, and the more people have IPv6 enabled, the more useful it is. But we don't all know when everybody else is going to migrate to IPv6. If only we could know when IPv6 would be better, faster, cheaper, then we could make rational decisions about when each of us needs to migrate. How can we possibly, though, figure out when when IPv6 will be better, faster, cheaper, according to the people who know? Well, gee, there's this body of network operators in North America that we could ask. So I'm going to ask. Right this second, I'm doing something that's never been done before as far as I know. Right this second, go to this URL, 3 questions. Radio buttons, pick the year that you think is the answer for each of those questions, hit submit, and I'll be back after the next lightning talk to tell you what the results are. You have to do it now because I'm going to shut down the poll in about 5 minutes so I can munge the data and come back and tell you what it says. So quick, everybody open your browser. bit.do/poll-html is the shortened URL, and I'll let you know what you told me. Thank you.
I think Lee just wants to come back up on stage again. All right, 3:30, we have NTP amplification attacks as presented by Patrick Gilmore. Patrick, last man standing to present this one.
Hi, everybody. My name is Patrick. I work for Markley Group. You'll notice my name is not on the slides. Those of you who are still awake and paying attention, that's because I didn't write them. Jared, being a wimp, decided to take off early. So I'm going to present for him. How nice. So if you've been living under a rock for the past 6 months, there's these things called NTP servers, and they can amplify UDP packets sent to them, and they have really big returns. You get graphs that look something like this. This is an actual graph. I don't remember where he pulled it off, but you don't need to know the scale to tell that this is way larger than it should be, and it's causing all kinds of problems. Enough of under the rockness. So this is clearly a well understood vulnerability, and I can't imagine any of you don't know about this. If you don't know anything about NTP attacks and you're confused by this, please raise your hand. Okay, then good. So now you know how it works and how it does. Jared, in case, again, you've been living under a rock, he started something called the Open Resolver Project, and this is essentially a copy of that. Now we have the OpenNTPproject.org. The methodology is pretty simple. He sends a packet to every IP address on the internet. He asks it for an NTP response, and then he measures not only whether he got a response, but how big the response was. How big the response was is actually important, because if you send a 100 byte packet and you get back a 200 byte packet, that's bad. But if you send a 100 byte packet and you get back 60 1500 byte packets, that's a little bit worse. He has made sure that he's only querying each NTP server once a week. So hopefully he's not causing too much havoc on the internet just by testing this. So we're going to look at the data set that he gathered on February 7th this year. 400 to 500,000 unique IPs responded. Each one of these can be used to at least anonymize an attack, and most of them can be used to amplify an attack, which is very, very, very bad. 13,000 unique ASs. That's a lot of the internet is used in this. So pretty much every RIR, he says the three major ones, but every RIR has some NTP servers in it. And the US, being the best, of course, wins. We have the most NTP servers that can be violated. How nice. Korea is the second. That bottom sentence, by the way, if you're reading it, might not sound exactly right. What he's trying to say is there's 80K in the US, and the second most is Korea at 30K. Korea, though, most of their NTP servers are in the same AS. The United States is a non-discriminatory abuser. We let every AS do it. So nice little graph. I don't know how well you can see it from the back of the room. The pie chart is, these slides will be posted later, right? Or they're posted already, maybe. I'm not sure. So if you want to look at it in more detail, you should get the slides. But you'll notice that the pie chart is divided into three major areas, with APNIC, ARIN, and RIPE roughly equivalent. I mean, they're not exactly, but you can tell just by the shape that it's not, there's not one that just dominates everything. The tiny little slice at 2% is AFRINIC. So I don't know why he called out LACNIC earlier, saying it had fewer. AFRINIC is actually the smallest. The bar on the far left is the important one. That's the United States. It gives you a pretty visual representation of how bad we are compared to the rest of the world. So I think this is pretty topical for NANOG to explain to its members that you guys should fix your NTP servers. Go to NTP project, OpenNTPproject.org, find out what your NTP servers are doing and fix them, please. So this is by ASN. As you can see, the Korean ASN, or I don't know if you can read that, but the far left one is the Korean ASN that has most of the 30,000 in Korea. And then it goes down after that. It's still pretty bad. Even the one on the far right, TWC, still has hundreds of NTP servers that are abusable. It's not like 3. There's actually still a lot of NTP servers inside of TWC, the one on the far right. Sorry to call you out. At least you were the one on the far right, TWC? So this is a graph that's actually, I think, really important, because this is the worst responders. These are the ones that respond with the most bytes per query. Here, the United States doesn't look too bad. We're in third place, in a far third place. Russia is the absolute worst, as you can tell. So, and then fast hosts-internet is the worst ASN. All of these ASNs need to be fixed, but these are the ones that if you know anybody here, this is where you should talk to them because this is the worst place that will send the most traffic back for the least effort from the botnet. Top IPs by the number of bytes. Think about this. There's a /16 that is 21 million. It's just insane. Something needs to be fixed here really bad. Number of unique IPs responding. Notice it's going down, and it's going down rapidly. So this is pretty good. But it needs to go down faster. So some conclusions. Sorry, this was a little bit of a boring talk. Remember, I didn't write the slides, but I'll take all the credit. And if you have any blame, remember to email Jared and Manish. Okay? So the vulnerability is everywhere. We don't discriminate, but the US does win by the most abusable servers, but everywhere has some. So even if you're visiting from another area, please look at your NTP servers and fix them. Just like your open name servers. Just like, I don't know, anything else. Make sure you're not a SPERF amplifier. The internet is not a fun place when people abuse things. When was NTP invented? I think 1985. And I was actually thinking about this before I came up onto stage. I was going, I think it was 85. And back then, every byte was precious, and things like TCP three-way handshake were a problem. So what we did, what they did, I had nothing to do with it obviously, is they did what they thought made sense at the time. One UDP packet in, send a UDP packet back. What could possibly go wrong? 30 years later, we're all screaming. So think about it, fix it, and please don't create any more like this. More important, the second bullet point, more important to understand the misuse potential in addition to the population at large. That's the magnitude graph. And that's very important that you get. Yeah, there are some NTP servers that can be used as a 2 times amplifier, but some that can be used as a massive amplifier. So we see different results when we examine the magnitude, obviously. The nice thing, though, is that if you keep your NTP server current, the vulnerability has been fixed. You don't have to do anything. Just, CV sup and recompile and you're done, right? Shouldn't be a problem. Patch your NTP servers. 4.2.7 P26 or later will not amplify. Shouldn't be a problem. So there are also configuration fixes if you don't want to upgrade to the latest one. You should add disable monitor. You can do other things too. I don't know every single possible fix, but there are ways in your ntp.conf to make sure that you do not amplify. And also make sure that the server never ever responds to loop info or IOStats requests. Do we have any questions? Does anybody not get the point that if you let one of these things loose on the internet that everybody else will be in trouble? It's pretty much the definition of cost shifting. I've talked to a lot of people who are like, well, I don't have time to fix this. Well, what you're doing is you're hurting everyone else. And for a society to do that is not sustainable. Michael?
Yeah, Michael Sinatra, ESNet. So one quick note, not just NTP servers or things that obviously run NTP. There are lots of things like NetApp filers and other devices. SAN management planes will often run NTP. And of course, Juniper routers and SRXs. They run it and they leave this stuff open by default. So what they allow you to do is make these kinds of queries. And they run, even if you're just running NTP as a client, because you actually enable all this stuff when you do that. So you have to take action to make sure that that stuff is closed off, whether it's ACLs or whether it's upgrading to the latest version of Junos or whatever you need to do. A lot of people will say, I'm not running an NTP server on this box, it's a Juniper SRX. Well, you are actually running an NTP server. That's the problem.
Outstanding point. Fix them all.
Phil Rosendahl from IS Prime. I wanted to point out another amplifier you did not mention is ChargeN. And that's actually, we actually see more attacks from ChargeN than even NTP at this point. I don't know if that's unique to us, but in any event, there is no legitimate purpose as far as I can tell to ChargeN. It is completely just enabled out of error. So if you have it enabled anywhere, you should disable it. You might want to consider filtering port 19. There's no purpose to it, but it's something else that you should be looking at on your networks.
Hey, I'm technically out of time. Do I have the ability to take one more question or not?
One more question. Last question, please.
Gentlemen,
Oh, sorry, he was there first.
Chris Murray, OpenDNS. It's not just NTP, like we're going to get this mostly fixed and then they're going to move on to something else. And there's lots of people who aren't securing their routers. So, you know, you're going to see on ISP end user networks, you're going to see these routers with responding to SNMP. So
Yes.
so we all need to basically figure out a way to secure these ancient protocols that have no security in them.
Yeah, they're not all ancient. SNMP v3 is pretty new. It's pretty much UDP that's the problem, because then you don't need a three-way handshake, right? So you can spoof the source address. So BCP38, secure all your UDP services, and if you don't, we'll find you and kill you. Thank you.
Thank you very much, Patrick, Jared, and Manish. Coming up next, we have Alexander Asimov. Alexander?
Okay, my name is Alexander Lyamin, and I'm from Curator Labs. We are a Moscow-based company. And at some point of time, we needed a tool for our network that could predict ingress traffic distribution so we could balance it better. So we decided that there is some good works in the field, like a KAIDA project, and we will just use them. What we found out later is that most of these projects, they usually use RAR data or BGP data and recreate paths and connectivity. But what was missing is lesser priorities, like a local path. So you could not get reliable traffic prediction from this data. There were no use for us. So we decided to create something more and improved on that, introducing active verification in the process. So initially we take BGP station data and BGP view data from different sources and the RAR data and approximate doing first approximation of AS interconnection graph. And then we go through the multiple stages of active verification. And since it's lightning talk, I couldn't describe all of them. The most simple and useful of them is just using a packet to the destination autonomous system with a route record flag. So if our model is right, we will receive this packet on the node that our model predicts. And if we're wrong, we will just adjust our routing policies and adjust the model, and in the end we will get it right. Meaning that we could actually recover such things as local pref and MED and other lesser priorities that taken place in BGP decision-making process. So at some point in time, we decided that if it's good for us, it might be good for community. And we created web interface for our tool, which right now could do next good things for you as community. You could explore a network graph, and since we recreate AS pref, local pref, we could establish AS relationships. Is it upstream, is it peer or paid peer, or is it a customer? Having this model, we introduced a constructor which allows you to easily design your autonomous system. If you connect to this upstream, will it be balanceable? Via means that you have like BGP path prepending. If not, probably it's not a good idea. Before that, we couldn't find out if it's possible, and we did this tool, and right now it works for us. It probably should work for you. And since we're scanning this network anyways, we decided to add some security data in the process. The core of technology is finding out AES relationships. There is interesting stuff about BGP. BGP is mostly not about network, but about the money. So idea is follow the money. If you're seeing someone peering with someone who's could sell this traffic to them, probably this is paid peer. So we could establish that, and I think we can do this quite reliably. What next? We also managed to recover all the lesser attributes and include them in the model, giving us good prediction of traffic ingress. And results could be seen in this nice dashboard on our website, and you can see what's going on with your autonomous system, or your peer autonomous system, or your neighborhood autonomous system, or your upstream autonomous system. What's the customer core, how many peers they have, and how many customers how many upstreams they have. What other people were trying to do in the field is to give us prediction, visualization of us paths taken from the BGP view. And we were trying to do path prediction. And it looks like this. We don't display any paths that in RIR or in BGP but could not be used for your particular autonomous system. We aspire to only display links that can actually be used and probably use it by your autonomous system. And there is also a tool which could allow you to engineer your traffic and see how your announcements will be changed when you play with your prepend policies. This sliders on the right side is the tool. And you can also try and connect new upstream for your autonomous system and see how this will change your connectivity. Nice, right? And since we're already scanning the network, we're also detecting such vulnerabilities as default route misconfiguration, DNS amplifiers, ICMP amplifiers, etc. We also display botnet activity, which was detected in your network. And we try to comprise a nice rate for you to reflect on how you do with your network performance and how network security, network performance, and network development. We also project botnet activity that is detected by our network on this graph. And as you can see, Russia is red hot. That's how these things are. What we're looking forward from this meeting. First of all, of course, it's work in progress. So there is a nice bug report button for that. And we're looking to extend features. So we want for your input how we can contribute back to community with this tool. For example, right now we're considering API, so you can do this pulling for our data automatically. So send us request features. And of course, you can establish a BGP session with our reflector, improving our data precision. What's on horizon? Having this model, we could definitely build beautiful tools like reverse trace route. And it's coming, hopefully it was coming by like this month, but probably next month, working on that. We're working on notification issues for your security notification system for your security issues like prefix hijacking, route leaks, and BGP dynamic loops. And of course, there is API. Once again, we're looking for your input, what kind of functionality you need for this, from this API, and how we can do this in sensible manner. Questions?
Thank you. All right. Thank you very much, Alexander. All right, Lee Howard, come and tell us the results of the lightning poll, a new first in NANOG history.
Sorry, somebody won the PlayStation 4? Do I? Who is that?
That was already given out. Paul Emmons won the third. Oh, okay.
It wasn't me, and I don't have that to offer. So the URL for the results is www.wleecoyote.com/results.html. And fortunately, the kind people at the back have presented those results right here. Now, I have to apologize because my coding foo is weak, and so my scripts did not parse as well as I thought they were going to. So I kind of hand jammed the data in Excel and then ported it back to here. So I try to include, so that's why I included the result detail here, the count, so you can go back and make sure that my numbers work out right. So the answers that we had to the first question, in what year do you think IPv6 will be cheaper than IPv4 or dual stack? And I left these questions intentionally vague because I want you to figure out what you think the question means. There were 111 responses. The average response was 2017, and the 80th percentile was 2019. So 80% of the 111 respondents said 2019 or earlier. In what year do you think IPv6 will offer better performance than IPv4? 110 responses, and the average was 2016, and 80th percentile again was 2019. I found that one especially surprising since I had 3 or 4 people yesterday saying IPv6 is already faster than IPv4, but hey, that's why I asked a whole bunch of people. And then the last question was, in what year do you think a significant number of users will have IPv6 only? And I expected that one to be a little bit further out, and indeed it was. The average was 2020 or later. I kind of pushed out 2025, saying, yeah, everybody was saying that's, that's going to be a long way out. However, when I look at the result detail for each of those, I'm suspicious that my math didn't work right there, because that doesn't feel like the average is 2020 or later there. So please feel free to go and play with the numbers yourselves. I will probably also put a link on this page to the summary of the data files so you can do your own parsing if you want to. One of the other interesting things that I found is, as I was looking at these, was the cheaper dates. So if you look at the detail there, and you say, okay, the 80th percentile is down at 2019, but it is kind of interesting that of the 100 respondents, 50, at least half said 2017 or 2018. So it's, it isn't all being pushed far out. So there are definitely really good reasons that, and it sounds like the rough consensus of people who are very well informed is it's not that many years away before IPv6 is better, faster, and cheaper. Thank you very much. I forgot to say, if you would like to ask different questions or wish that these questions were worded differently, run your own survey.